The Atom Replicator Hypothesis. Have you ever seen an episode of Star Trek where they walk up to a machine, request a specific meal, and the machine instantly creates that food? What if that idea were not pure science fiction, but a theoretical possibility? The Atom Replicator Hypothesis, theorized by Harrison Fisher Geary, explores this exact topic. Let's break it down. Anything that takes up space or has weight is considered matter. Matter can exist as a solid, liquid, or gas. The building blocks of all matter are atoms, and an atom itself can be broken down further into three main components: the nucleus, protons, and electrons. The number of protons and electrons determines an atom's chemical properties, bonding behavior, and electrical charge. Each unique combination creates a fundamentally different building block of matter. Another way to think about this is that all atoms are ingredients. An atom with 5 electrons and protons is a different ingredient compared to an atom with 2 electrons and protons. With this in mind, consider a cheeseburger. It is only a cheeseburger because of the arrangement of its atoms. If that arrangement were changed, it would no longer be a cheeseburger. It might instead become a microphone, a clown nose, or a diary. The object is defined entirely by how its atoms are ordered. Therefore, to create a cheeseburger out of thin air, like in Star Trek, one would need to determine the correct atomic arrangement and organize those atoms accordingly. This seemingly simple method immediately runs into problems. The first is scale. The number of atoms involved is so large that we cannot even imagine how many zeros there are. In a single cheeseburger, there are roughly 10 septillion atoms. That number has 28 zeros. This means that there are more atoms in a cheeseburger than there are stars in the observable universe. The number is so unfathomable to the human mind that if you sat down and tried to count to 1 septillion, it would take 3 quadrillion years to finish. Even if every grain of sand on Earth were multiplied by 1 billion, you would still reach only about 70% of that number. Now suppose the problem of arranging 10 septillion atoms were somehow solved. Even then, the challenge would not be over. The size of the atom presents another obstacle. Atoms are among the smallest known structures in existence, alongside quarks and other subatomic components. If you filled a shot glass with atoms, which is exactly what happens when you pour any liquid into it, it would contain roughly 200 billion times more particles than there are cells in your body. Manipulating an object at this scale would be incredibly difficult without touching or disturbing neighboring atoms. With these two looming obstacles, it would be easy to see how humanity is still light years away from creating a machine that can replicate food. However, atomic manipulation is not purely theoretical. There is already a tool that can move a single atom. It is called the atomic force microscope. It can grab and move individual atoms. Scientists have used it to arrange atoms into simple structures, including the so-called molecule man, a stick figure drawn using just 28 atoms and measuring 5 billionths of a meter tall. So, what about the numbers issue? There is certainly no way that any human could calculate the exact order and arrange 10 septillion atoms to create a cheeseburger. But what if humans didn't have to? What if there were another form of intelligence that could process and organize this information at a much faster speed? Well, there is. It's called artificial intelligence, and it is improving at an exponential rate. In theory, a Star Trek-style replicator machine would require an artificially intelligent system equipped with a vast array of atomic force microscopes. The first step would be calculating the atomic configuration of a cheeseburger. Once that configuration was processed and stored, the machine would attempt to assemble the atoms into the required arrangement, effectively causing the cheeseburger to materialize. Right? Unfortunately, additional problems would emerge. Atoms do not behave like Lego blocks. Simply placing them next to one another does not guarantee stability. Atoms may repel each other, collapse into unintended structures, or release large amounts of energy. Successful assembly would require precise control over energy, charge, and bonding conditions at every step. The atomic force microscope demonstrates what is possible at small scales, but it does not solve these larger constraints. There is also the problem of information. The data required to describe even a single cheeseburger at the atomic level would be so vast that all existing human data storage would be insufficient. Even if such information could be stored, and even if atoms could be assembled at a rate of 1 trillion per second under ideal conditions, the process would still take approximately 300 million years. If reality is composed of atoms, then where does rearrangement stop being possible? The short answer is physics. Known physical laws impose limits on time, energy, and information that we currently cannot overcome. These constraints prevent us from walking into a kitchen, saying the word steak, and watching a replicator machine instantly create food. Yet history suggests caution when declaring something impossible. Flight was once a dream. Crossing oceans was once unimaginable. Time and again, humanity has challenged perceived limits. So, the question may not be whether the replicator will ever exist, but whether its creation lies years or millennia away.
He flipped the file again to show a new picture. This one was much more twisted. I had to look away for a moment and regain composure. No one should ever have to lay their eyes on a scene as horrific as what was in that picture. No one should.